Okay, so in our last video, we talked about what a limit is. Now we're going to talk about how to find one. And this video is all about how to find limits using graphs. So this is the first part is called graphical approach to limits. So remember how I said when I ask you what a limit is, I'm going to ask you what is the value as x approaches a certain number from the left and the right. So as x approaches a number from the left and the right. In this case, we're going to be approaching 2 from the left and from the right. So let's first talk about what happens as x approaches 2 from the left. So as the x values increase to 2. So in red here, what I'm asking you for, what is the limit as x approaches 2 from the left? And let's see, what's the name of this function? The name of this function is f of x, of f of x. So, and here they happen to have a picture for me on your homework assignment. The picture is not going to be there, so you can't always just rely on looking at the picture. So we're actually looking at a table first. If I said graphical, I meant table. So we're going to use tables first and then graphs later. Okay, so we're going to approach 2 from the left, which means I'm going to take this function here and I'm going to substitute in values for x. And those values are going to approach, the x values are going to approach the number 2. So the first thing I'm going to do is I'm going to substitute in the number 1.75, which means I'm going to take my calculator and type in 1.75. That's not a great place to write that, so I'm going to be typing in, using this formula right here, 1.75 cubed minus 8 over 1.75 minus 2. So when I do that, I get a decimal that's approximately 10.5625. Okay, then I'm going to do it again with the number 1.9. So I'm going to take the same formula, substitute in the number 1.9. So when I put in 1.9 for x, I'll have 1.9 cubed minus 8 over 1.9 minus 2. So I'll type that in my calculator. I get a number 11.41. When you type in 1.99, you'll get 11.9401. And then when I type in 1.999, I get 11.994. So I'm going to take a step back and think, okay, as the x values increase until I get really close to 2, not exactly 2, but I just want to get really close because we are approaching 2. We're not finding what happens when x equals 2. We just want to find out what happens when the x values get close to 2. Well, when the x values get close to 2, my y values were 10.52. And then I'm looking for something I can write with. So it was 10.562, and then it increased to 11.41, then it increased to 11.9, 11.99. I'm guessing if I typed in my calculator 1.99999, I would get a number really, really close to 12. So as the x values increase towards 2, the y values are getting closer and closer to 12. So we would say that the limit as x approaches 2 from the left of f of x is 12. Okay, now let's try doing that the other direction. So we're going to approach 2 from the right side. And from the right side means the numbers that have to decrease to get to 2. So like 2.001, 2.01, 2.1, 2.5. So we're going to start at 2.5 and we're going to approach 2 from the right side. Now the notation for that is going to be, what is the limit as x approaches 2 from the right? And we say from the right with a little plus sign that looks like it's in the exponent's place. So what is the limit as x approaches 2 from the right of f of x? So I'm going to go back to the same formula, but instead of typing in the x values I had earlier, now I'm going to type in 2.5, 2.1, 2.001, and 2.001. So when I type in 2.5, I get 15.25. When I type in 2.1, I get 12.61. When I type in 2.5, oh, sorry, not 2.5. When I type in 2.01, I get 2.0601. And then when I type in 2.001, I get 12.006. So as our x values, or that highlighter again, as our x values approach 2 from the right side, getting close to 2, the y values get, let's say, start at 15, but then they go down to 12.6, 12.0, 12.00. They get really, really close to 12. So we'll say the limit as x approaches 2 from the right-hand side of f of x equals 12. Well, that's cool. So the limit as x approaches 2 from the left of f of x is 12. The limit as x approaches 2 from the right of f of x is 12. That's cool. But what's happening at 2? Well, at 2, this graph has a hole. There's nothing there. It's undefined. And then I've written over my formula, but if I were to substitute 2 right here in for x, I would get an undefined value because I would get 0 over 0. So at 2, I get a value that's undefined. Well, what am I supposed to do with this? Well, we have this rule here. Let me scroll down a little bit. Okay, so I want to point out this part. Here's notation. The limit of f of x as x approaches some value of c from the left side is written like this, where we have that negative or that minus up there. And then the limit as x approaches some value of c from the right side is written where you have that plus sign. Now, in order for a limit to exist, this is the important part. So let me get my highlighter out. I'm going to pick purple. Okay, in order for a limit to exist at a specific value, the limit as x approaches that value from the left must equal the limit as x approaches that value from the right. And then we can say that the overall limit, notice right here that there is nothing written. So the limit as x approaches c, period, is that value. So as long as whatever we get for the left is equal for the limit from the right, then we say that the limit, the overall limit from both directions, is that specific number. So what that means in this table up here, if I can scroll back to it, come on. Since the limit as x approaches 2 from the left was equal to 12, and the limit as x approaches 2 from the right is equal to 12, then I can say that the overall limit as x approaches 2 from both sides, and I don't have any thing up here, of f of x is equal to 12. Okay, so let me show you a couple of your problems. So when you log into your Delta Math account, you are going to see, you're going to see an assignment here, limits with tables and graphs. So all of these, you can't really see what I'm pointing to, all of these are part of one assignment. So this is one assignment for today. And it looks like a lot, but notice you only have to do 2 problems here, 2 there, 3, 3, 3, 3, 3, 3. So you only have a few problems from each section that you have to go, but it's divided up into sections so that you get plenty of practice with each type. So you'll just we'll just start up one section. Okay, so this one is saying, notice that we don't have a graph here. So we don't have a graph. We can't just look at the graph and see. We have to use the function values in order to determine the answers to each question. So the question is right here. What's the limit as x approaches -3 from the left? So I want to pick values. If I think of a number line, 0, -1, -2, -3. I want to approach -3 from the left side, so that's these values right here. So I'm going to approach -3 from the left, and I'll say like maybe -3 point, well that's comma, 0.1. And then Delta Math does all the calculations for me. Okay, well, what if I want to get closer to -3? So like maybe -3.01. Okay, 1.95. Let's get even closer to -3.001. Get even closer to -3.0001. Closer, 0.0001. Now notice as the x values are getting closer to -3, because like -3.0001 is so close to -3, they're pretty much the same value. The y values are getting closer to a number, closer to, let's see, 1.9, 1.999, 1.99999 is really, really close to 2. So I'm going to say that the limit as x approaches -3 from the left is 2. Okay? Then I'm going to be asked for what is the value as x approaches -3 from the right. So now I'm going to go back up. I'm going to approach -3 from the right this time. So that means values on the right side of the number line that lead to -3. So I need numbers like that are really close to -3, but not quite -3. So maybe something like -2.9. And then even closer to -3, -2.99, -2.999. And I'm just going to type in a bunch of 9s till I get closer and closer to 3. So as my x values get closer and closer to -3, the y values are getting closer and closer to 2.0000. So pretty much closer to 2. So I'm going to say that the limit as x approaches -3 from the right of f of x is 2. Okay? So earlier I said as long as the limit as x approaches -3 from the left and as x approaches -3 from the right, as long as those two are the same, then the overall limit from both sides is that number. If they're different, you would say the limit doesn't exist. And that's what this DNE stands for. So DNE means does not exist. And if you have ever watched the movie Mean Girls, then you know what I'm referring to when I say the limit does not exist. And so now you can know what that means. All right, then you'll see this extra question right here. What is f of -3? So they just want to know at -3, what's happening to that function. So you'll just go to your table, type in that number -3, and it tells me that value is 2. And that will be important later on, like whenever the limit and the value are the same. But for right now, that's all you need to know. So you'll submit it, and you'll hopefully get a check. Now there's another section in here that you'll need this information for. So let's see, I've already got 1 out of 2 problems correct. I just need to get 3 more for this section. Limits from a table. Okay, so this is a second type. And now let's see, this time we're approaching -3 again. I know this is probably bothering some of you. You'll learn soon that I'm not a perfectionist. Okay, so if you're ever doing this and you want a new problem, I want a new problem right now because I just approached -3, so I'm going to see if I can click and get a new problem, so that way I don't have to approach -3 again. So is there another example? If you ever get stuck and you just want to see an example, oh no, I've lost all my tools. Where's my tools at? Okay, so if I scroll and click show example, I can go back to the original problem and I want to try this. Okay, well, we're just going to have to approach -3 again. So let me draw that number line here. Something different should happen this time as we approach -3. -1, -2, -3. Okay, so as I approach -3 this time, it says from the left. So I'm going to approach -3 from the left, which means I need numbers like -3.1 and -3.01 and -3.001 and again and again. Okay, well, it looks like as the x values are approaching -3 from the left, the y values seem to be going 2.96, 2.98, 2.98, 2.98. Let me get even closer. 2.98, 2.9815. Let's just put a whole bunch of zeros in there and see what happens. 2.9815. It looks like it's getting really close to 2.98. So I'm going to try 2.98. Okay. Now as x approaches 3 from the right, now I need to approach, sorry, -3. Oh, I'm approaching 3, not -3. Well, let's try this again. Clear the table. Okay. Erase all this. We need to be approaching 3 from the left and the right. That negative threw me off. Okay. Starting over. Make a number line. 0, 1, 2, 3. Okay, let me approach 3 from the left. That means I need numbers leading up to 3 from the left side. So numbers right here, about 2.999. So in my table, delete all that. 2.9 and even closer, 2.99. Oh, not 2.99. Even closer, 2.999. Even closer, add another 9 in there. Another 9. Another 9. Another 9. Another 9. Okay, let's look at what's happening here. As the x values are approaching 3 from the left-hand side, the y values, it started off at 4.73 and then it went negative. Then it got positive and decreased a little bit, decreased. I'm having a hard time seeing because see, like 4.73 is totally different. 4.79, it looked like it was going somewhere and then it got really negative. So let's play around with this for a little bit and let's see if I put another 9 in there and another 9. I'm having a really hard time seeing what the y values are getting close to because I've got a negative number here, and then all of a sudden there's a positive, and then a negative, and then a positive, and a positive. The y values really don't seem to be getting to be the same. So when that happens, we'll say that that limit does not exist. Okay, so let me clear that ink away. That's not going to erase for a second. Okay, so then let's try approaching 3 from the right. So I need numbers that are slightly bigger than 3. So I'm going to approach 3. So 0, 1, 2, 3, 4, 5. I'm going to approach 3 from the right side. So the right side of 3 is this area. This area. I'm going to get closer and closer to 3 from the right. So that means I need numbers right here that are really, really close to 3, but not exactly 3. So I'm looking at numbers like 3.1. That's close to 3. Oh, wait. Don't submit that. I meant to put the 3.1 up here. 3.1. Okay. And then 3.01. And then 3.01. So I'm trying to type in numbers that are going to get me really close to 3, but not exactly 3. And I see as, oops, that's not 3.01. Ignore this 2 right here. As the x values get closer and closer to 3, the y values are more consistently. They're getting more and more consistent to -8. And again, that 2 was a mistake. So they're getting closer and closer to -8. So we'll say that as the x values approach 3 from the right side, the y values approach -8. Now, what is the overall limit from both sides? Well, the limit from the left doesn't exist, and the limit from the right is -8. These two values need to be the same in order for this final box to exist. If these two are not the same, then we'll say the overall limit from both sides does not exist. So I'll type that in. Okay, now as far as what is f of 3, I'm going to clear the table, and I'm going to see what happens to the y value when x is 3. The output or the y value is -8. Submit my answer. That is correct. So here's what you're going to do. After you watch this video, I'm getting ready to stop it. You are now prepared to do these 2 sections. And then, actually, I'll go ahead and talk about the infinity from the table. Let's talk about these. Let me clear off this ink. Okay, so I've got the same scenario here. I'm going to look at these limits. This time I'm approaching -infinity. Ooh, what does that mean? Okay, well, let's make a number line. -infinity is on the left, +infinity is on the right, 0's in the middle. Now, infinity is not a number, it's just an idea, so I need numbers that get close to -infinity. So I'm just -infinity. So I'm going to start with -10. So let's put -10 right there. Okay, now I want to get closer to -infinity, so I need to pick a number closer. So maybe -100. That's still not quite -infinity, but it's further, smaller number, further to the left. I'm trying to get my pointer back. Okay, so let's try -100, and then maybe -1000. What I'm doing is I'm entering numbers that get closer and closer to -infinity. And I'm trying to see if there's a pattern with my y values. So as my x values get smaller and smaller, is there a pattern with the y values? Are they getting to be approaching a consistent value? I'm seeing 1, 2, 1, 3, some 2s, a 1, a 2. I'm not seeing a consistent pattern here, so I'm going to say that this limit doesn't exist. And then likewise, if I want to approach infinity, in my table, I'm going to type in values that get bigger and bigger. So we'll start off with 10 and see what happens to the y. So when I put in 10 for the input, the output's -2.49. Put in 100, -1.07. Let's see if we see a pattern here if I enter bigger and bigger and bigger numbers. Well, I'm starting to see a pattern. Notice here, I'm starting about right around here. I start to see values get closer to 2.5. 2.499, 2.499, and I'll right here when I enter a big value, I get a y value that just goes ahead and says, you know what, that's really close. That's so close to 2.5. We're just going to say it rounds to 2.5 because it looks like the calculator doesn't go past maybe this decimal place. So we're going to say that as the x values get larger and larger, the y values get closer and closer to 2.5. Submit my answer. Yes, that's what I want to do. And there we go. All right, so now actually you have more information. You can do this first one, the second one, and the third sections, and then all types is just a mixture of all of those. So you can actually do the first half of the assignment, all these first 4 sections. Then in our next video, I'll show you how to do the graphic one.